minus 3 minus j4 times t, and for this part we have this one times e minus 3 plus j4 times t and whole times u of t. And why we multiply it by u of t? Because again it is one-sided or unilateral Laplace transform. Questions? Please correct this one in my notes. Yes.
How did you go from the 5 squared plus 65 plus 25 to 5 plus 3 minus G4?
This?
No, it's the very first line when you changed it, the 5 squared plus 65 plus 25 to the 5 plus 3 minus J4.
Okay, from here?
That's all the screens.
Okay, sorry. From here?
Yeah.
Okay, just you need to find the roots for this one. Do you know how to use quadratic equations? Okay, just if you find, you will get these. You just separate them, okay? It has two roots. One is at minus 3 plus j4, another one is minus 3 minus j4. Okay, this is the last one, but we are going to make it easier.
Can you go back for 1 second? Did you see that
Sure.
there's something you need to change from what you had the notes before?
Yeah, this part I put j, just correct
Oh,
it.
okay, thank you.
Okay, for this part, you get a factor of 10 times e2 minus 3 times t times this term. If you multiply by 2 and then divide it by 2, this inside will be cosine. Do you remember, students, ECED 2001? Do you remember this equation? So cosine, is there anybody who doesn't know? Yes, Justin?
No, that's just the identity where cosine, or 2 cos is equal to e to the jt plus e to the jt.
Yes. Cosine alpha, or whatever you see over here, I call it alpha, is equal to e to j alpha plus e to minus j alpha over 2. So if I divide this one by 2 and multiply it by 2, this part is cosine of this angle. And this is because I multiply it by 2, that's why I have now 20. So the Laplace inverse is we had this term plus 20 times this one. Questions? The procedures for solving this thing real and this thing complex are the same. For proper rational functions. Practice assessment problem 12.5. Okay, the third one was repeated real roots of d of s. So what if we have repeated real roots? So for example, we had a function like this, f of s. So k1 over s plus k2 over s plus 5 to 3 plus k3 over s plus 5 to 2 and plus k4 over s plus 5. What is the maximum order for the denominator?
4.
4. So it means you have how many roots? 4 roots. How many are at minus 5?
3.
3 times 3. Okay. So the first one is at 0. So for the second term, write the maximum order and decrease it by 1, and then it decrease this one by 1. So you have 3 plus 1, 4. 1, 2, 3, 4. So you need to find 4 coefficients. Questions? Okay. For finding K1, again, the same procedure as we did before. Multiply both sides of the equation by s and evaluate it at the root, which is 0. So if you do this, you will get K1, which is 20. For K2, which has the maximum or it has the highest order, the same procedure. So multiply both sides of the equation by s plus 5 to 3 and evaluate it at minus 5. So this one will be 0, this one will be 0, this one is 0, and we have just K2. And over at this side we have minus 400. So K1 and K2, the same procedure. But after this, to find K3 and K4, there is a slight change in the procedure. So this one was our function. So for K3, multiply by s plus 5 to 3, both sides of the equation. So you will have this and differentiate both sides with respect to s. And after that, evaluate it at s equal to minus 5. So the first step is multiply both sides of the equation by s plus 5 to 3. So you will get this one. Now get derivative with respect to s, both sides of the equation, this side and then this side. So we have d over ds of this term plus d over ds of this term. This one, there is no, because it is a constant. And for this term and plus this term. So if you get derivative for both sides of the equation and evaluate it at s equal to minus 5, K3 will be minus 100. K3. Okay, questions? So for K3, one more time. You see the denominator is s plus 5, but square. Don't multiply it, both sides of the equation by s plus 5 square. Multiply by the highest order. Then derivation with respect to s, and after that evaluate it at minus 5. For K4, again, we are not going to multiply by s plus 5. We multiply both sides of the equation by s plus 5 raised to the power 3, both sides of the equation. Get the first derivation with respect to s, and then get the second derivation with respect to s from both sides of the equation. And then evaluate it at s equal to minus 5. You will get k4 equal to minus 20. Questions? One more time. For the repeated real roots of d of s, again, we are talking about proper rational functions. So if we have repeated real roots, k1 over s plus k2 over this term plus k3 over this one and plus k4 over s plus 5. So you put the highest one for k2, that is the best way. You can do it whatever you want, but you try to put s plus 5, 3 for k2, and then decrease 1 order s plus 5 whole square and decrease 1 order s plus 5. That's it. So 1, 2, 3 or 3, 2, 1. So for k1, the same procedure we already know. For k2, again, the same procedure. But for k3, we multiply by s plus 5, 2, 3. Again, get derivation with respect to s and evaluate it at s is equal to minus 5. And for the last one, this one, multiply it by s plus 5 to 3. Get derivation with respect to s and get the second derivation. Why 2 times? Because see, 3 minus 1 is 2. So you need to repeat it 2 times. First derivation d over ds, again after that d over ds. Then evaluate it at s is equal to minus 5. Questions? Eric? Clear? Okay. So get the inverse transform from this one. So this is 20 times over s. The inverse will be 20 times ut. And this one will be minus 200 times t squared e power to e to minus 5t minus 100 t e minus 5 and minus 20 times e to minus 5t. And y over here I put 20 times 200, not 400. Again, refer to those tables. Two times over s plus 5 to 3 will be t squared e minus 5t. So that's why I have 200 over here. You have the tables on broad space. You go and check them. So practice assessment problem 12.6. Questions? Okay, for the last one, repeated complex roots of d of s. Again, we are just considering proper rational functions. Okay, for example, this is our function f of s. These are the roots. So the roots are complex and they are repeated. Why repeated? Why repeated?
Just squared.
Because of the squared over here and squared over here. I have two roots at -3 plus j4 and two roots at -3 minus j4. So I have repeated and the roots are complex. So the procedure for repeated complex roots of d of s. What was that? Questions? Okay. So this is our function. We write it k1, just be careful. For this one, whenever you see repeated complex roots, k1 over s plus 3 minus j4 whole square plus k2 over s plus 3 minus j4. So this is the second one and this is the first one. Second, 2, 1. And for the third term, we don't write K3. We just say K1 conjugate. So how about the denominator? Denominator is s plus 3 plus j4 whole square plus K2 conjugate, not K4 anymore. And denominator is s plus 3 plus j4. So for repeated complex roots, k1 over this one square plus k2 over this one without square, or decrease it by 1. And the third term is k1 conjugate. This one is this square and k2 square s plus 3 plus j4. Yes, Josh.
If both roots were complex conjugates of each other, you have to write still k1, k2 conjugate.
If what?
If like both those roots, like the 5 plus 3 minus 3 and 4, and the 5 plus 3 plus 3 and 4 is the complex conjugates of each other.
Yes, that's why we wrote it. We write it like this. So your question is, if I'm wrong, just correct me.
No, it's okay. Like if it was like, say, 5 plus 3, if they're both plus j4, like 1 was j5.
Because you are saying, because this is the conjugate of this one, that's why I use K1 conjugate. Yes.
Okay.
So this is our function. For finding K1, the same procedure multiplied by the denominator of K1, both sides of the equation, and evaluate it at the root of this first term. You will get minus 12 for K1. For K2, again multiplied by s plus 3 minus j4 whole square. Is that clear? Again, multiplied by the whole term, which is square. It means multiplied by the denominator of K1. Then after that, d over ds, and evaluate it at the root, which is minus 3 plus j4. So K2 will be minus j3, or 3, the angle is minus 90 degrees. So you have K1, you have K2. What is K1 conjugate? This is minus 3. What is the conjugate of K1? K1 is minus 12. What is K1 conjugate?
Minus 12. Same because the imaginary is 0.
Yes. Because we don't have the imaginary part, so we have the same value, minus 12. How about K2 conjugate?
Positive J3.
Positive what?
Well, if it was already negative, then it becomes positive J3.
Just the angle or just the imaginary part. Because here we have 3 and the angle is minus 90 degrees. So the conjugate of K2 will be 3. The magnitude is the same, but the angle is 90 degrees. Clear? Or minus J3 will be J3. Just change the sign of the imaginary part. If it is positive, make it negative, or if it is negative, make it positive. So this will be our f of s, and if you get the inverse transform for this part, again I use the previous equation of cosine, so you will get this. These two together and these two together. And don't forget to multiply by u of t. Questions? Practice assessment problem 12.7. So we have rational functions. We divided them into two parts. One is the proper one, another one is improper. So which one is proper? Which one is proper?
When the bottom's bigger than the top.
What's that?
When m is greater than
M is greater than n. Yes, that's right. Thank you. So we call it proper. So again, proper, we divide it into 4 types. The first one was real distinct. Second one was complex distinct. Third one was real repeated, and the last one complex repeated. So any questions? Okay, now if we have improper rational functions, so it means what? If we have improper rational functions,
M is less than n.
what's that?
M is less or equal to n.
N, yes. So this one is proper or improper rational function?
Proper.
This one? Improper. Why? What is the higher order for the numerator?